Hi students, we can start the question paper discussion with questions from 2022 JEE main entrance examinations. These questions are from the topic concentration terms, that is from the chapter solutions. I will read the first question, you please listen. When 200 ml of 0.2 molar acetic acid is shaken with 0.6 gram of wood charcoal, the final concentration of acetic acid after adsorption is 0.1 molar. The mass of acetic acid adsorbed per gram of carbon is dash gram. Listen please, this question can be simply represented as 200 ml of 0.2 molar acetic acid is shaken with 0.6 gram charcoal. Then this charcoal will adsorb some amount of acetic acid from this solution and the concentration is reduced to 0.1 molar. Then we need to calculate the amount of acetic acid adsorbed by 1 gram of charcoal. First of all, we can calculate the number of equivalents of acetic acid present in the initial solution. That is equal to its normality into volume in liter. That means the number of equivalents of a solute in a solution can be calculated using equation normality into volume in liter. But here normality is not given, molarity is given. If molarity is given, then normality is equal to molarity into X. For an acid, X is called basicity. Basicity means number of replaceable hydrogen atoms. Here for acetic acid, number of replaceable hydrogen is equal to 1. Therefore, normality is equal to its molarity. Then substituting for normality and volume in liter, the number of equivalents of acetic acid initially present is equal to 0.04. Now we can calculate the number of equivalents of acetic acid present after adsorption, that is equal to normality into volume in liter. Volume of the solution remains the same, that is equal to 0.02. This is the number of equivalents of acetic acid present after adsorption. Therefore, the number of equivalents of acetic acid adsorbed is equal to number of equivalents initially present minus number of equivalents present after adsorption. Therefore, number of equivalents adsorbed by the charcoal is equal to 0.02. So, the mass of acetic acid adsorbed is equal to number of equivalents of acetic acid into equivalent mass of acetic acid, that is 60, that is equal to 1.2 gram. This is the mass of acetic acid adsorbed by 0.6 gram of charcoal. Therefore, mass of acetic acid adsorbed by 1 gram of carbon is equal to 1.2 divided by 0.6, that is equal to 2 gram. So, the final answer is 2 gram. Then the second question is, the neutralization occurs when 10 ml of 0.1 molar acid A is allowed to react with 30 ml of 0.05 molar base MOH twice. The basicity of acid A is dash, in bracket M is a metal. In this question, an acid A combines with a base MOH twice. The formula of acid is not given, so its basicity is not known. We need to find out the basicity of the acid. Please listen. The volume of acid A reacted, we can take it as V1, that is equal to 10 ml. Molarity of the acid reacted, that is given 0.1 molar. The normality of the acid N1 is equal to molarity into X. X is basicity, we need to find out, that is equal to 0.1 into X. Then the volume of base reacted, it is taken as V2, that is equal to 30 ml. The normality of the base N2 is equal to, this is the molarity of the base into its acidicity. Acidicity means number of replaceable OH minus ions, that is equal to 2. Therefore, normality is equal to 0.1 normal. For an acid-base neutralization reaction, the equation is V1N1 is equal to V2N2. That means number of equivalents of acid is equal to number of equivalents of base. Then substituting for V1N1 and V2N2, then basicity of acid X is equal to 3. That means here the answer is 3. Then the third question. 1 liter of solution of H2SO4 contains 0.02 millimole of H2SO4. 50% of this solution is diluted with deionized water to give 1 liter solution A. In solution A, 0.01 millimole of H2SO4 are added. Then total millimoles of sulfuric acid in the solution is dash into 10 raised to minus 2 millimole. Look here, in the first part of question, it is given that 1 liter of H2SO4 contains 0.02 millimole of sulfuric acid. Therefore, molarity of sulfuric acid solution is 0.02 millimolar, because molarity is a number of moles of solute present in 1 liter solution. In the second part, 50% of the solution, initial volume of the solution is 1 liter, its 50% means 500 ml, it is diluted to 1 liter. For the dilution of the same solution, the equation is V1M1 is equal to V2M2. V1 is the volume taken for dilution, that is 500, and the M1 is its molarity 0.02. V2 is the molarity after dilution, that is 1 liter or 1000 ml, and the molarity of the resultant solution can be calculated, that is equal to 0.01 millimolar. In the third part, it is given that 0.01 millimolar sulfuric acid are added to the solution. Then the total number of millimoles of sulfuric acid present in the solution is equal to 0.01 millimoles already present, 0.01 millimoles now added, then total number of millimoles is equal to 0.02, that is equal to 2 into 10 raised to minus 2 millimoles. This is the final answer. Next, question number 4. A commercially solid concentrated hydrochloric acid is 35% HCl by mass. If the density of this commercial acid is 1.46 gram per ml, the molarity of this solution is. In this question, percentage by mass and density of a commercial concentrated HCl solution is given. The percentage by mass of concentrated HCl, that is small x, is equal to 35%. Density of the solution, small d, is equal to 1.46 gram per milliliter. Then the relationship between molarity, percentage by mass, and density is molarity into molecular mass of solute is equal to 10 into d into x. Molecular mass of solute is 36.5 because the solute is HCl. 10 into density of solution is 1.46. Percentage by mass is 35. By solving this equation, molarity of the solution is found to be 14 molar. So here the answer is 14 molar. Next, question number 5. 20 ml of 0.02 molar hypo solution is used for the titration of 10 ml of copper sulfate solution in the presence of excess of potassium iodide using starch as indicator. The molarity of Cu2 plus is found to be dash into 10 raised to minus 2 molar, in bracket nearest integer. Two equations are also given. The first equation is 2Cu2 plus 4I minus gives Cu2I2 plus I2. Second equation is I2 plus 2S2O32 minus gives 2I minus plus S4O62 minus. This question states that 20 ml of 0.02 molar hypo solution. Hypo solution means sodium thiosulfate solution is used for the titration of 10 ml of copper sulfate solution. This is a redox titration reaction. But copper sulfate solution cannot be directly titrated by using sodium thiosulfate solution. That is the reason why this titration is carried out in presence of potassium iodide solution. So that copper sulfate solution will first of all react with potassium iodide solution and liberate iodine. And this liberated iodine can be titrated by using sodium thiosulfate solution. The two reactions involved in this titration reactions are given. In the first equation, copper sulfate combines with potassium iodide and liberate iodine. And in the second equation, this iodine converts sodium thiosulfate into sodium tetrathionate. In the first equation, the oxidation state of copper changes from +2 to +1. Therefore, change in oxidation number X is equal to 1. In the second case, there are 2 sulfur atoms in sodium thiosulfate. Therefore, oxidation state of 2 sulfur atoms is equal to +4. In sodium tetrathionate, there are 4 sulfur atoms. Oxidation state of 4 sulfur atoms is equal to 10. Therefore, oxidation state of 2 sulfur atoms is equal to 5. Here, change in oxidation number of 2 sulfur atoms is equal to 1. So, in both cases, change in oxidation number X is equal to 1. It is given that volume of sodium thiosulfate solution used for titration V1 is equal to 20 ml normality of sodium thiosulfate solution is equal to molarity into X. For an oxidizing or reducing agent, X is called change in oxidation number. Here change in oxidation number is equal to 1. Therefore, normality is equal to molarity. The volume of copper sulfate solution used for titration, V2 is equal to 10 ml. For a titration reaction, the equation is V1 N1 is equal to V2 N2. Then substituting the values of V1, N1 and V2, the N2 can be calculated. That is equal to 4 into 10 raised to minus 2. This is a normality of copper sulfate solution, which is also equal to its molarity because change in oxidation number is equal to 1. So here the final answer is 4 into 10 raised to minus 2. Next question number 6. Chlorophyll extracted from the crushed green leaves was dissolved in water to make a 2 liter solution of magnesium of concentration 48 ppm parts per million. The number of atoms of magnesium in the solution is x into 10 raised to 20 atoms. The value of x is dash in bracket nearest integer. Given atomic mass of magnesium is 24 gram per mole, Avogadro's number is equal to 6.02 into 10 raised to 23 per mole. Here in this question, the volume of the solution prepared is 2 liter. It is a very dilute solution in aqueous medium. So density of the solution is approximately equal to 1 gram per milliliter or 1 kilogram per liter. Therefore, mass of solution is equal to 2 kilogram, that is equal to 2000 gram. Here the concentration of magnesium in solution is given as 48 ppm. ppm means parts per million. That means 48 gram of magnesium is present in million gram or 10 raised to 6 gram solution. Therefore, we can calculate the mass of magnesium present in 2000 gram solution, that is equal to 48 divided by 10 raised to 6 into 2000, that is equal to 96 into 10 raised to minus 3 gram. Now, number of moles of magnesium in 2000 gram solution is equal to mass of magnesium divided by atomic mass of magnesium, that is equal to 4 into 10 raised to minus 3 moles. So, the number of atoms of magnesium is equal to number of moles of magnesium into Avogadro's number, that is equal to 24 into 10 raised to 20 magnesium atoms. So here the answer is 24 into 10 raised to 20 and the integer answer is 24. Then question number 7. When 800 ml of 0.5 molar nitric acid is heated in a beaker, its volume is reduced to half and 11.5 gram of nitric acid is evaporated. The molarity of the remaining nitric acid solution is x into 10 raised to minus 2 molar in bracket nearest integer, and the molecular mass of nitric acid is 63 gram per mole. In this question, volume of an HNO3 solution is given, that is equal to 800 ml and its molarity is equal to 0.5 molar. This solution is heated so that some amount of HNO3 is evaporated and the volume is reduced to 50% of the initial volume. So now the volume of the solution is equal to 400 ml. 800 is the initial volume. It is reduced to 50%. Now the volume is equal to 400 ml. And the weight of HNO3 evaporated is given as 11.5 gram. So we can calculate the number of moles of HNO3 evaporated, that is equal to 11.5 divided by 63. This is the number of moles of HNO3 evaporated and the volume of the solution is reduced to 400 ml. Then we can calculate the number of moles of HNO3 initially present in the solution, that is equal to its molarity into volume in liter. Initial molarity is 0.5 and the volume of the solution 800 ml divided by 1000, that is equal to 0.4 moles. This is the number of moles of HNO3 initially present in the solution. The number of moles of HNO3 remaining after evaporation is equal to 0.4 moles initially present. 11.5 divided by 63 is the number of moles evaporated, that is equal to 0.2175 moles. This is the number of moles of HNO3 remaining after evaporation. So molarity of the solution after evaporation is equal to number of moles of solute into 1000 divided by volume in milliliter, that is equal to, by substituting these values, we will get 54 into 10 raised to minus 2 molar. So molarity of the solution after evaporation is equal to 54 into 10 raised to minus 2 molar. So here the integer answer is 54. Then question number 8. The boiling point of a 2% aqueous solution of non-volatile solute A is equal to the boiling point of 3% aqueous solution of non-volatile solute B. Find the relationship between their molecular weights. In bracket, consider both the solutes as non-electrolytes. Listen, this question states that two solutions of non-electrolytes A and B have same boiling points. If two solutions have same boiling point, then their delta TB will be same. That is, delta TB of solution A is equal to delta TB of solution B. Delta TB is the elevation boiling point, which is a colligative property. If two solutions have same colligative property, then the number of moles of solute in those solutions will be same. That means number of moles of A is equal to number of moles of B. Number of moles of A is 2 divided by molecular mass of A. Number of moles of B is 3 divided by molecular mass of B. But these two will be same. So 3 into molecular mass of A is equal to 2 into molecular mass of B. This is a relationship between molecular mass of A and B. So here the answer is option number 3. Next question number 9. 250 gram of a solution in bracket aqueous contains D-glucose. The percentage of carbon in bracket biomass present in the solution is 16.7. Find the molality of the solution. That is, the question is a 250 gram aqueous solution of D-glucose is given. Its concentration is not given, but the percentage by mass of carbon in the solution is given. We need to calculate the molality of the solution. Here the mass of solution is given as 250 gram and the percentage of carbon in the solution is equal to 16.7% by mass. That means 16.7 gram carbon is present in 100 gram solution. Now we can calculate the mass of carbon present in 1 mole glucose. 1 mole glucose contains 6 carbon atoms, therefore it is equal to 6 into 12, that is equal to 72 gram. So the number of moles of D-glucose in 100 gram solution is equal to 16.7 divided by 72. But the initial amount of solution is 250 gram. Therefore, number of moles of D-glucose in 250 gram is equal to, this is a number of moles in 100 gram into 250 divided by 100. Now we can calculate the mass of glucose present in 250 gram solution. This is a number of moles of glucose into molecular mass of glucose 180, that is equal to 104.375. This is a mass of solute present in 250 gram solution. Now we want to calculate the mass of solvent in solution. 250 gram is a mass of solution minus 104.375, this is a mass of solute. 250 minus mass of solute is equal to 145.625. This is a mass of solvent present in solution. Therefore, molality of the solution is equal to weight of solute into 1000 divided by molecular mass of solute into weight of solvent. Substituting these values, we will get 3.98 molar. So here the molality of the solution is 3.98 molar. Here the answer is option number 2. Next question number 10. 2 liter of 0.2 molar H2SO4 is reacted with 2 liter of 0.1 molar NaOH solution. The molarity of the resultant product Na2SO4 in the solution in millimolar is in bracket nearest integer. Listen, this question says 2 liters of 0.2 molar sulfuric acid react with 2 liters of 0.1 molar NaOH solution. When two substances react, we can equate the number of equivalents of substances that react. That means 1 gram equivalent of a substance can always completely react with only 1 gram equivalent of another substance. So first of all, we can calculate the number of equivalents of sulfuric acid in the solution. That is equal to normality into volume in liter. Here molarity is given 0.2. Molarity into basicity is normality. Here basicity sulfuric acid is 2. Therefore normality is 0.2 into 2. Into volume of the solution is 2 liter. Therefore the number of equivalents of sulfuric acid in the solution is equal to 0.8. Then number of equivalents of NaOH is equal to its normality 0.1. Normality is equal to molarity because acidicity of NaOH is equal to 1. And Olimoti solution 2 liter, therefore number of equivalents is equal to 0.2. From this it is clear that number of equivalents of NaOH is lesser than number of equivalents of sulfuric acid. Therefore, 0.2 equivalents of NaOH can react with only 0.2 equivalents of sulfuric acid. The remaining 0.6 equivalents of sulfuric acid will remain unreacted. That means 0.2 equivalents of NaOH combines with 0.2 equivalents of sulfuric acid to form 0.2 equivalents of product, that is sodium sulfate. Therefore, number of equivalents of sodium sulfate formed is equal to 0.2. So, number of moles of sodium sulfate formed is equal to number of equivalents by X. For a salt, X is equal to number of positive or negative charge in a molecule. Here in sodium sulfate, number of positive or negative charge is equal to 2. Therefore, number of moles is equal to 0.1. That means 0.1 mole of sodium sulfate is now present in 4 liter solution. Now the Olimoti solution becomes 4 liters because we are mixing 2 liters of sulfuric acid and 2 liters of NaOH. Thus the total volume becomes 4 liters. Therefore, molarity of sodium sulfate solution is equal to number of moles divided by volume in liter, that is equal to 0.025 molar, that is equal to 25 into 10 raised to minus 3 molar, that is 25 millimolar. So here the answer is 25.